Hello, dear friends. I'm glad to see you all again on our JaCoV webinars. We're back from our small vacations. It takes around just a couple weeks. And I'm glad to be here again with you. I hope you missed our webinar. I missed them as well. Okay, so my name is Roman Meerson, and I'm a driver of JaCoV initiative. And I'm glad to see you all here. I hope that today's webinar would be interesting and useful for you, as I hope all our webinars. Before I welcome here our today's speaker, I want to remind you that in the description of our talk, there is a couple links. First of all is feedback form. We expect you to submit some feedbacks on our webinars and to tell us how you feel about them. So we try to read all the feedbacks and try to make our webinars better. So please spend a couple minutes just to fill this form. It's quite simple, just some stars, or if you have more time, you may either add there some text. So we will try to make our webinars really better. So we really appreciate if you will do this for us. Also, there is an email where you may submit your talks. We waiting for you. If you would like to be a speaker, if you would like to present, oh, sorry, something with my eye. So if you would like to be a speaker on our webinars, we really welcome you all. We help to prepare your talks from different steps. So if you have your talk, we may give you this opportunity to present it on our webinars. If you have only willingness to prepare your talk, we also may help you with this. And if you have an idea, we also helping you with to do your talk here with us. So please text us on this email, OrgJaCoVCommunity@epam.com. And even if you're not from EPAM, even if from EPAM, so that doesn't matter for us. We are worldwide webinars stage. So please text us and we will help you to prepare your talk, and you will be here on our webinars, on our JaCoV webinars. Also, we have Telegram chat, so please join it. And we have community page on CommunityZ, so you may subscribe there and receive notifications about future webinars, not to miss them. And all the information is coming here. So guys, I see that you some kind of quiet in chat, so please type something in chat if you can hear me. Type pluses, type hi, hello, some smiles, please. So anything, I would just see that I'm not alone here. just something, please put it in the chat. Oh, so something happened with my eye. I don't know what. Okay. I hope it will be better. Okay, I'm still waiting something from you in the chat. Nice. I see some messages. Hello, guys. Okay, so let's not waste a lot of time, and let me welcome here our today's speaker. Our today's speaker is Ram. Ram, please join me here in online. Hi, Ram. How are you?
I'm fine, Roman. Thank you very much. Thank you for introducing me.
Okay, so before we start with the talk, Ram, could you please tell us in few words, what would be your talk about?
Okay, so this talk about is the serverless technology, because gradually every in industry we are moving toward the serverless. So even is the banking, even is the home entertainment solution, anything we are moving to a serverless technology. So nobody want to take care of hardware. So but we have some challenges there and while moving to serverless. So we will discuss all about what is serverless and what are the benefit of moving that and what all the pitfalls we have and how can we we can say overcome this pitfall and we can choose the serverless technology for our need.
Okay, well, sounds really interesting. Okay, guys, so we'll start really in a few seconds. I would just remind you that we are waiting for your questions here in the chat in YouTube. I will monitor all the questions and I will try to answer all of them. So don't miss a chance to type your questions here during the webinar. Don't wait to the last moment because we probably won't have time for your questions in this case. So type your questions here in the chat. I will monitor them all and we'll ask all these questions in the end of the webinar to Ram. Okay, Ram, are you ready? We seems we have some connection trouble. Yeah, you are back. Seems. Are you ready? Great.
Yes, I am.
Okay. Okay, cool. So I'm sharing your screen, so you may switch to presentation mode. We can see it now.
Okay, so let me start.
Okay, good luck.
Yeah, thank you. Are you able to see my screen? So Roman, my screen is visible, right?
Yep, everything is fine.
Hello.
Yeah,
Hello.
everything is fine. Everything is good. Seems we have some connection problems still.
Yeah, Roman, you're there?
Yes, can you hear me?
Yeah. Okay. So are you able to see my screen?
Okay, seems we have some connection problems. I will try to fix them immediately. Just give me a second, guys. I will type to RAM.
Yeah, I'm back.
Okay, cool. Can you hear me now?
Yes, I am able to hear you.
Great. We can hear you. I can see your screen, so you may proceed.
Yeah, okay. So if you have any issue in between, please let me know because I am on screen sharing mode now. So maybe I will not able to see if anybody is not able to see me, right?
Well, if anything will be not good, I will tell you.
Yeah, okay. So I'm moving to the screen sharing mode and I have shared my PPT that is the crack serverless computing. So we are going to talk about this, the serverless computing, the journey towards serverless computing. So before proceeding is about me. This is Ram Naresh here as a working as a solution architect in EPAM, having more than 60 years of experience and I am TOGAF certified enterprise architect. I'm AWS certified associate, Azure certified expert, and Oracle certified Java developer, and also Big Data Hadoop certified. That is all about me. So let's move to agenda. We will talk about what is serverless computing, and we will talk about the difference between the serverless computing and the traditional computing which we are doing, and what all are the serverless provider we have. Majorly, we will talk about 3 serverless provider here, and then we will discuss few use cases like the finance, how we can use serverless in the payment system, and what all the problem challenge could be there and what all solution can be there. And then after we will discuss about the other use cases that can be help to move to a serverless computing rather than have the on-prem. Okay. Okay, moving further. Serverless computing. What is serverless computing? So if we talk about serverless, anybody have idea what is serverless computing? You can mention our chat and what is serverless computing, and you can tell the small description what you have in your mind when we talk about the serverless computing. Okay. Roman, do we have any answer?
Not yet, but let's give a couple more seconds because we have a lag between us and between guys. So Let's give them a couple more seconds to type their answers in chat, if they have any. Okay, we have first answer. It's AWS Lambdas. Also, yeah. Serverless computing is a cloud computing execution model in which the cloud provider allocates machine resources on demand, taking care of the service on behalf of their customers. Thank you, Dima. I think really theoretical answer. We not need to manage server for our application. Creating application without thinking any hardware architecture. These are the answers we have in chat.
Yeah, exactly. So the first answer, AWS Lambda, that is, we can say that is the implementation of serverless computing. But when we talk about serverless, it means we don't need to think about any server. But do we exactly, we are deploying our code without server? Exactly not. The code always run in any server, but that is the serverless environment. The code will be deployed on server that is managed by somebody else. Somebody else means any serverless provider. Serverless provider means any of the provider will provide the services to us, and we are using their services, and by using their services we are using the server provided by them, and we will deploy our code to that. Okay. Next is, what is exactly serverless? Serverless means we have to think about only the function, only the service which we are going to deploy, nothing else. Rest of the things is taken care by service provider. Next one, the infrastructure cost. Infrastructure means we have a computing, we want to store something, and we need a networking between our server, database, or some third-party tool, or some the static file storage. We don't need to think about that. We just need to write our code, and everything is abstracted from developer. The computing power, the storing, we no need to think about that, because every serverless provider like the AWS, Azure, GCP, they have on their different mechanism to provide this facility. Now, if we have a server on our on-prem, and we have to monitor them, and we have to provide some patching, we have to solve their problem, like if we have a hardware crashes, anything there, so that can be done by us. But if we go for serverless, the monitoring, patching, the problem management, everything is taken care by serverless provider. So the serverless provider, I am referring here the different cloud provider, like the three example taken: AWS, Azure, and Google Cloud Platform. Now, what is the other thing? The capacity management. How we will do capacity management if we not go serverless? So in that case, if we not go serverless, that means the scaling of server, we have to add on more server, and we have to specific DevOps team who will add a new server to us whenever we need a more server, or if there is a need to scale down because we don't have a much load. In that case, the DevOps team will do that. But by moving to serverless technology, everything would be automated to us, and automating scaling, availability, capacity to fit our current need, that is being taken by the serverless provider. So we never go over utilization, or we never go for under. So the provisioning will be done on the basis of our utilization. Whatever we require, that is being provided by the serverless provider. Okay. Moving further. So now, how we evaluate towards serverless? So first of all, when we start our journey in computing, so first of all, we have a hardware, that is, we have a very big server on one of the room, and we have to manage that. We have done networking, we have done virtualization, the operating system, and the containerization that come very later on. And we have to create a runtime environment, and then after we have to deploy our application on that. And application have multiple functions. because like one application need to create a multiple modules, then these modules has to be has been developed as a function, and that has been put into application. So that is the on-prem what we have. And next we have a next era. In that the three MR part, like hardware, networking, and virtualization, that is taken care by the cloud provider. Or you mean to say any infrastructure provider who provide us some infrastructure and we deploy our application on their infrastructure. So we can say is IaaS. IaaS means infrastructure as a service. So infrastructure is provided by somebody else. In the next step, we have till runtime, means hardware, networking, virtualization, operating system, container, and runtime. That is provided by the platform as a service provider. Again, we can say any cloud provider. Here, we have to manage our application, on deploy our application onto any of the virtual machine. It can be on some on-prem virtualization provider, or it can be on cloud where virtual machine has been provided and we deploy our application. In the next step, there are some provider who tell us that we have application. Don't need to worry about that. You just deploy your application, and we will cater all the functionality to you. You can go for Java, you can go for .NET, you can go for Node.js, or you can go for any technology you want, and we would able to provide your platform, and you just need to deploy your function. In the next, we have the software as a service. We don't need to do anything. The functionality is also provided by some service provider. If we talk about the Salesforce is providing some the tool that is related to sales to us, and we can generate lead there and we can use there. The another example is we can say Google has provided some Excel document and PPT on the fly on cloud, and we can use their software and we can just work on creating a document on the cloud, and we can and that's it. Okay, but here if we have a customization application and we want to customize our module, in that case our area of concern is the functional as a service. Like we have application for banking, we have application for IoT, and we want to deploy it, and we don't need to worry of anything, and we need to just worry about to create our module and deploy somewhere. In that case, that is the functional as a service, and our today's talk is depend on totally on functional as a service. Any question till now? Okay. Let me wait for 1 minute because it takes some time to get your answer. Questions? Roman, do we have any question?
No, I don't see any at the moment.
Okay, so let me move to next slide. That is the benefit. Okay, so now we have discussed about the serverless and what all the things we can do with serverless, and what the functionality we are going to deploy on serverless, and the area of concern for deploying functionality on serverless. So now we will discuss benefit of serverless computing. First of all, the cost effective. If we talk about any of the service provider, the cloud provider, they are charged according to the uses. Whatever compute service we have used, whatever the storage we have used, and whatever the storage we have in REST, on the basis of that, they are charging to us. Similarly, for specific to serverless, they charge for the time we have application running. For example, we have one application and we have a request, and it take 500 ms to complete the request. So the serverless provider will charge only for that 500 second. So for further granular level, they have a minimum unit for this calculation. If we talk about AWS, in AWS Lambda, we have a one unit is 100 ms. So for 500 ms, we will get a charge for 5 unit. So every unit have a different price. So even around 1 million request is already provided free of cost by AWS. The next one, elastic scalability. Scalability means whenever we need the number of requests has been increased, and we want that our server should be increased, that is automatically has been done by the serverless provider. They increase the number of instances as per the user need, and when there is no need and the need has been reduced, it automatically remove the instances which is not in use. Zero maintenance. So because we don't need to think about the hardware, and that is taken care by serverless provider. So as a company and as a developer, we don't need to think about deployment part, and there is no any maintenance there. Automatic high availability. High availability means we have applications running on one region. I am expecting here that the audience have some specific knowledge of region, availability zone, and the availability set. Or in other word, we can say if they don't have, so I can provide a brief information about that. The availability zone is we have some we can say area in which we have deployed the machines, and if specific machine has been down, what should be done in that case? So it means the one area, one city, one country is completely down and it is not accessible. How we can maintain the availability of particular service? So any of the serverless provider provide is multi-region application. We can deploy our application to multi-region, multi-availability zone. In that case, if one of the region fail, the serverless provider automatically use the another region to cater the request. Quicker turnaround. We can say it's an agile friendly mechanism. Developer just need to think about the, we can say, granular part which they want to deploy, and once that deploy, we don't need to go for the process of bug fixing and deployment script to deploy to some virtual machine and then provide to testing team. But by using serverless, we can just deploy our application, and we can provide a URL of that particular link to testing team, and they can test it. That's it. Deployment complexity. Earlier, if we have a legacy code, in that case, we have a number of modules and we need to club together and create a deployment package that can be deployed on particular container, a particular virtual machine. But we talk about the functions and the smaller unit, and we already have a serverless provider and they are providing a mechanism to deploy that. We can just deploy that particular module on the fly on some module on cloud, and there is no any complexity, and we don't need to configure multiple modules. It will work as a stateless. Every function will be work as a stateless, and they can work independently. Multilingual support. Multilingual, here I'm talking about the computer language in which the software can be developed. Either it can be a Node.js, Express.js, or Java, .NET, or Go language, or any other language on which we want to deploy application. The serverless provider provide us the mechanism to deploy our application on the particular the compiler, and developer don't need to think about the deployment, and they don't need to think about how the application will run on server. Okay, so then in the next slide, till now we've seen that there's a lot of facility which serverless is providing, but because while going serverless, we have some challenges also. The challenges is that Right now, we have a complete liberty that we can handle our project by on, but by going serverless, what all pitfall can be. So we have a two type of category here. One is one-time challenges, and another is the recurring challenges. One-time challenges is environment setup, like how we can set up an environment on what all things we need to do. Even it's a very easy because everything is provided by serverless, but still there's a challenge because everybody need to understand how we are going to deploy on serverless technology. The less portability. Portability means we have application that is running on on-prem and we want to deploy on some provider like AWS and GCP. So any serverless technology we choose that is more dependent on the provider. So if we have code that is deployed on AWS, it would be very difficult to migrate it to the GCP and Azure. So the more we are going to serverless, the more we are sticking to one particular cloud. The vendor control. Similarly, because we are using their mechanism and everything is in their control, we don't have any access to hardware and anything, and the application is developed according to their integrations, so we don't have any control over there. Composability. In a normal application which is deployed on the virtual machine or any containerization approach, we can create our orchestrator layer and we can orchestrate it according to the business logic. But if we go for serverless, there should be some specific tools that should be provided by serverless technology to compose and to compose multiple services to provide the consolidated response to use. That is again a one-time challenge because once we done the composability, we have orchestrate, and going forward there would not be any challenge per se. Again, the last one is integration testing. As we discuss about the composability and where we have to, we can say, think about the multiple orchestrator layer and how they can communicate and how the logic would be there. Similarly, in integration, we have different URL and that is developed, that is we can say deployed on multiple zones, multiple URLs would be there. So integrate them and to have an integration testing, that is the challenging task. And again, it needs some time to orchestrate all the integration point into I can say in consolidation, then the testing can be done. Now we move to the recurring challenges, that is testing and debugging. If we have application on on-prem or everything we have on our control, we can look into the debugging and logging. Then if there is an issue, we can check that this is the issue and we can debug it. But on serverless, we don't have access to server. We are not able to debug any issue if we have on any Lambda function or a cloud function. We don't have any mechanism to test it locally. Security is because every function that is be deployed on serverless technology that is deployed on one particular VM or the virtual machine which is provided by the serverless, but we don't have any access to it, and the serverless provider can deploy multiple vendor code into one machine. So in that case, there can be a security issue if there is any leakage or memory leakage from one tenant to another tenant. Now, let's suppose we have chosen some serverless technology and we have created a Lambda function. But if that Lambda function is providing answer in, we can say, 15-minute or 10-minute, in that case, the time of execution is cost to us. Rather than if we have a dedicated server, we have deployed on machine, in that case, that is, we can say dedicated we have provided, but on serverless, every single unit we have to pay. So the long running process will have more charges, and that is we can say the problem on serverless side. If we have a long running process, better to go for the traditional approach. The cold startup. Anybody have any idea of cold startup? Do we have any answer?
I think guys need more time because we receive some answers after some time. So uh, let's uh, let's wait a bit more.
Mhm.
So
I'm
maybe we'll have
waiting
some answers.
because yeah, I'm waiting so that I
Yeah.
want that audience.
But
Yeah,
while we're waiting, we have a question. So maybe let's answer this question while we're waiting for the answers. So, as a developer, could we tune parameters like amount of RAM memory available for certain use cases? And in these cases, we would still be talking about serverless?
Yes, so if we want to tune for one particular, we can say request, because during development we would have a different memory sizes, so we can try on the look we can say on test environment when once we are going to develop it, we can choose the what which particular memory size and the timing is suitable to us.
Okay, okay, that's good.
Okay, so
Thank you
so
for the
we, so
answer.
if we talk about lambda function, we have a different configuration. Whatever memory we want to provide that particular function, like we want to provide it 256 MB, we want to provide it 512 or 1024. That is depend on how much memory we require for a particular function, and the time of execution is required. So let's suppose if we have a Java application, definitely it will take a more memory, and we should assign more memory to it. And on the other hand, if we have a Python and Node.js application, that will take very less memory, and it can be easily executed in 1 to 8 MB.
Okay, I think we may proceed further with cold start time and your presentation.
Okay. The cool startup, once we deploy our applications on very first time, when server is getting up, it takes some time. After server has been started, so it is able to cater the request after that. Similarly, if we have a serverless technology and we do not have a certain request at specific time, after some time, what happened? All the instances has been stopped. So whenever we have a new request, the server gets start up, the function has been deployed to server, and once it's ready, then it would be ready to cater the request. So these cold startup is also is calculating in your number of unit you consume per particular request. So if we have a very less request and every time the cold startup is being happen, so it's not we can say wise to us to go with the serverless, because it's taking much time to get to the request. The maximum resource limit. Uh, every cloud provider have a limitation, the number of in a time limit as well as the concurrent request limit. The reason behind that, they don't want any spike on particular function, because it can be some bug there, it can be some what I can say, some intruder provide use some tools and they are hitting our application to increase the load. So in that case, the service provider has a limit that they cannot handle more 100,000 requests concurrently, and every request can have at least at most 300. We can say 15 minutes. More no more request ever. One request can have at most 15 minutes. So after that, the service provider automatically kill that request. So that limitation is also being put there, but we have a more long running request that is taking more time to that. In that case, we have to connect to service provider and need to have a specific permission to get it done. The last is stateless. As I discuss and specify earlier that the stateless meaning for one application, one function, once it provide the response, then it goes. So that means for that particular request, if we want to babe multiple requests into a single unit, in that case we have some separate tool which can help to we can say babe that request. So but even as a function, they will get a event from some outside, and they provide the response, and after that their job has been done. So that is the challenge, again a challenge for serverless technology. So I'm going to move further. Okay. Now, so we have talk about the benefits, pitfalls for serverless technology. Now it's a decision. Either we should go for serverless computing or for traditional computing. If you see in this diagram, in a traditional computing, wait for a moment. Let me give some place. So you can see here the everything are all there in a single unit. So like we have a front end logic, we have a back end logic, we have a security mechanism, we have a database, that is we have a single unit. But if we go for serverless, we break down front end as a different, back end as a different, security as a different mechanism, and database call is a different. So that is the difference between traditional and serverless computing. Now, the decision how to go that, which one should choose. So if we have a development from scratch, we want to design a new application, we don't we need to think about from scratch, then we can go for serverless technology. If we want to go for cost effective, like we don't have much calls and we don't want to provision a VM, dedicated VM, and in that case the serverless technology is good. We don't want any maintainability, we don't want to maintain hardware, that's we can say choose some vendor to do that. In that case serverless technology is good. The scalability, we don't need to think about the increase or decrease the provisioning, that is want to we can say uh, we want to handle we want that it should be handled by somebody else, then we can use the serverless. If we have a cloud skills, like we have a dedicated resource who can develop the cloud application that can be deployed on Azure or AWS Lambda or anywhere, then we can use the serverless technology. Now, on the other part, in which cases we should go for traditional approach. We have some code that is developed on legacy, we can say, technology, and it is already developed, and we want to migrate to cloud. It would be better we don't go for serverless. We can choose the virtual machine, and by using lift and shift, we just deploy on VM, just like we have deployed on-prem. If we want a more security, we don't want to that somebody else is handling our code. In that case, we can go for the traditional approach. Even the service provider have a multiple technologies they are providing, like Java, .NET, and Node.js, and some other. But if we have some specific technology that is not available on cloud, in that case it would be better we have some VM and deploy our application there. So in that case, traditional approach is good. The third party integration, because third party integration is more suitable to have a control in our hand rather than to put code into the serverless function. In that case, it's better to go with traditional approach. We have a lot of integration with on-prem. We have some of the application that is running on on-prem, and other are running on the serverless or on some we can say cloud. In that case, we should go for the traditional approach rather than to choose serverless. Okay, the last one that is most important, and we don't want to stick to any cloud provider. In that case, it would be better we choose to go for traditional approach, just deploy application on container or virtual machine or at cloud or on-prem, rather choosing a serverless technology. Okay, so that's all about the serverless and what are the benefit we have discussed. We have discussed about the pitfalls, we have taken the decision. Now it's a time to see the vendors and what all services they are providing. So first of all, AWS. In AWS, we have some of the services which can be used to deploy the serverless functionality, like AWS Lambda, which can be used to deploy function as a service. API gateway, which can be used to we can say as a authentication layer, as a caching mechanism, or as an intermediate layer to backend system. In that case, we can use gateway, API gateway, the DynamoDB for database, NoSQL database, S3 for storing the files and images, videos, and we can use that. SNS if you want to send some notification. That is the services provided which can be used to architect any serverless, we can say, artifacts. Similarly, we have Azure. In Azure, similar to Lambda function, we have Azure function. Similar to API gateway, we have API management. CosmoDB is equivalent to DynamoDB. Blob storage for storing the file and the objects. SNS equivalent, we have a event grid. If we talk about Google Cloud, we have a cloud function. We have a APJ, we have a cloud endpoint. And for DB, we have a big table. And for storage, it's a cloud storage. And for cloud message storage, is similar to SNS. So I have a complete mapping of each and every service which is provided by AWS, Azure, and cloud. So you can ping me to get this mapping. Even all the services from Azure and AWS, rather than only these services, the other mapping I also have. So if anybody wants, so I can share the detail and they can ask over chat. Okay. Now let's discuss some few use cases. The first use case I have taken that in a finance. So I have taken a use case of the payment system. In a payment system, let's suppose one bank want to send a payment instruction to another bank, and what all things we need to do. So if you think about the serverless computing and in finance, what all things serverless in finance we are looking for. First of all, any bank, any finance service want to use the technology advantage, like the latest technology they want to move. They want to migrate off from their infrastructure that they are handling by their own, but they want some infrastructure that somebody will handle their infrastructure. They want high performance, and they don't want any infrastructure management, and they want a transparent scaling that they don't want to do it by themselves. Anybody can do for them. And they want to pay, they don't want to pay for ideal time. In nutshell, we can say they want to get rid of maintaining the infrastructure and somebody else can manage that, and they don't want to think about the deployment. They want to get rid of DevOps part, and they want that any provider, any serverless provider, any cloud provider can handle that. So the challenges which we face, like in a payment system, the challenges is that any API which we develop for the finance, they want a security. API security. They don't want that their API security is compromised. It should be dedicated to them and nobody else can access it. Once they send a payload to another bank, they want it should be a digitally signed. It should be integrated with key management system for encryption and decryption, and they want a quicker response. Like once they want to send a request to another bank, immediately it should get a response. And the another challenge is that call. like in because as we talk about that the function is the stateless, and we don't have a state. In that case, how we will provide the synchronous response? Next is transformation. If we talk about the API gateway and any other technology, they have some specific payload. Like we have a payload in XML, we have a payload in JSON, but some of the bank have payload in XML, and they don't how they want to send the XML file over to another bank, because in between the technology will use JSON format. Like API gateway don't have a mechanism to transform the JSON file to XML. So how we can achieve that? Okay. So, and again the concurrent execution. So, like the number of requests we can have a concurrent execution, but in serverless technology we have a limit of 1000 function at a time. So how we can say cater that request that is more than 1000 requests. So then these are the problem. Now we have a solution for each and every these pitfalls. Like we have API gateway in private subnet. So in AWS or any cloud, we can create a gateway in private subnet that can handle, because in that case, that is specific to that bank only. We can have a VPN connection to that VPC, and only that bank can access that particular VPC. Now, for payload digital sign, we have a cloud HSM, we have a KMS. KMS we cannot use because KMS is a shared resource. So we want a dedicated resource that is specific to bank. In that case, cloud HSM is the better choice to choose. Now, if we choose cloud as a HSM, there is a problem that cloud HSM need a client that should be on client side. So we cannot create a client on any Lambda function. In that case, we need some mechanism workaround where we can create a temporary client. So EC2 instance we can use to create a temporary client for cloud HSM. Further, that client can be used as a layer in a Lambda function. But the situation is that if there is any change in username password in cloud HSM in future, again we have to create a new client, and that need to be deployed to Lambda function. So for immediate response, we have a SNS. After API gateway, we can put SNS. Once we get a request for API gateway, the SNS send a response back to user, like your request has been received. Further is to send a response to the Lambda function, and it can trigger a Lambda function that can do some tasks. Okay. Now, for the asynchronous, we can have an integration with the external API. That is, we can choose inside Lambda function, we can access the other external API, the URL of API, and we can send a synchronous response. Sorry, the Lambda function. So for transformation, we can use the Lambda function. We will use the transformation logic inside the Lambda function. We can create the utility function that can be used to transform JSON format to XML and XML format to JSON. And for concurrent execution, we have a DLQ that can handle concurrent request. So this is the use case for payment system. In the next slide, I will also show you the architecture diagram that can be used to handle this problem. So if you see, as I explained in the previous slide, we have a API gateway at number 2. We have a SNS. SNS send request to Lambda function. Lambda function store data into DB. That is the DynamoDB, Aurora DB. And after saving data, it transform in Lambda function, and now it's time to we can say digitalize, we can say sign that document. In that case, we have a HSM ENI, that is the interface that is used to connect to HSM. Here we cannot directly access lambda function, HSM from lambda function. We should have some we can say again the private cluster ANI in between that can access the HSM. Here you can see the HSM client that is used to create the client library that will be deployed to each lambda function. It's a one-time job before we can say starting the work. So in future, if you want to change password, only then it is required. So once that has been deployed, we can have a lambda layer that can be deployed on lambda function, and lambda function can integrate with HSM and and we can say digitally sign the document and then send that document to the outer side, that is the we can say bank software to another bank, and in that case we would have a side to side VPN between the two banks, and that can be have the common platform, like one bank cannot access the other bank over public internet. It is the we can say uh, it is the network which is we can say dedicated to that two banks only. So here are the some other services like CloudWatch for monitoring HSM endpoint, and we have a S3 for storing the deployment. We have a key management system for password management for the HSM and DV, and SNS for sending a notification. So all these use case have these 14 services which we have used to deploy this particular use case. Now we have okay. So before moving further, so if anybody have any question on this use case,
I don't see any at the moment, and I think let's move on just to fit in time, so we'll have more time for questions in the end of our presentation. Okay.
okay. So we have the other common use case, we want to deploy a web application, we want to deploy a backend service, we want to deploy a data processing, like we want to use a real-time processing and MapReduce, and we want to create a chatbot, or we want to create the Alexa's skill kit for Alexa, or we want to automate the IT automation we want to do. So these are the different use cases we can choose as a serverless. So I'm going one by one. If we talk about web application and backend, we have some services on AWS like front door, which can be work as we can say the front layer for mobile application, and we have API gateway. In API gateway, we can have the caching mechanism. S3, we can store a static website, and we can trigger a lambda function if there is any of event change on S3. Similarly, the front door can access directly to Lambda function by using API gateway, and it can also store some data to DynamoDB by using some Lambda function. So everything we want to monitor what is going on, then we can use this cloud monitoring. Okay. Moving further, the IoT case. In IoT, we want to capture, we can say, we want to capture data as a generic. We want to capture data for home. We want to capture data the light bulb. We want to capture data for factory. We want to capture data for temperature. So these are the different use cases for IoT, and we have a different IoT devices that can be used for that. So in between, we have a IoT framework that is provided by AWS. On backend, we have some services like Kinesis, we have easy to instances, we have a Lambda function, DynamoDB, IoT event, and IoT analysis that can be used in case of IoT. So now I have taken an example of this IoT, and this is the factory data we want to capture, and it use the services like IoT site-wise, IoT green grass, and lake formation. This is majorly the analytic we want to do. So if on factory we have store some IoT devices and they capture data and it is sent to the edge location that is on IoT site wise. Once data has been captured, that is sent to the sidewise on cloud. And on cloud, we have a different use cases. What we want to do, we want to do some analytic, and we want to store data by lake formation, and we want to generate some IoT event to SNS, or we want to send some notification to user. And on other side, analytic, we want to have the dashboard report that manager can use. So these are the services which is provided by IoT related, and every serverless provider have some different services. So I have taken example of this AWS, and you can also check this reference architecture diagram on AWS site. You can just search the predictive quality, and you can find this diagram over there. And if you want to get more understanding on that, then you can get it. Okay. Next is for data processing. For data processing, we have a kinesis services that is used to capture data from someone and the outside, and that data is triggered to Lambda function, and that has been stored to DynamoDB, where business user can use that data to get the trending, how the data is going. So majorly this use case is the social media, where the real-time data processing is required, like what are the favorites of each user, what is the some similar we can say social images are going on. So to capture the similar type of data, we can use this architecture. Moving further, we can create a chatbot, like just like if you see in any banking or any if you call customer care, they have their own app, and before reaching to actually customer care executive, there's a bot who answer you what you want to do. So similarly, we can create our own chatbot. We can there would be some lambda function in behind. We can have a DynamoDB, we can have a SNS or any other AWS services. Once we get some we can say request from client, it trigger a lambda function get data from DynamoDB and return back to user, but all further option would be there to cater their request. So that similar type of chatbot we can also create by using these services at AWS. Moving further, again, there's another example of chatbot. These are the services, like if we want a security that nobody can interrupt and nobody can do some cross-site scripting, we can have a guard duty. And the code pipeline is for deployment. And here you can say if we want to generate some alarm, we have a CloudWatch. SNS already talked for notification. We have a chatbot service that can be send data to Slack and Chime. Okay, and the last one, there is Alexa. In Alexa, we want to create our own skill. Right now, in Alexa, they have already we can say specific back we can say service for them. But if you want our own Alexa, we want a language translation for us, and somebody speak in some language, and we want the similar response and in another language. That type of we can say the skill we can create for Alexa. So in that case, we have Alexa skill, we have a lambda function, we have a poly service, we have a translate service. We can use S3 bucket and DynamoDB. By using these services, we can create a the Alexa skill, and we can deploy it to the Alexa toolkit. Okay. The last use case is automation. The automation is at some particular time we want to destroy some instances, or at particular time we want to increase the instances, or if there is any mishappening happen to one of the instances, we want to start a new instance. So these type of we can say automation we can use. We can create a script. We have a Terraform script which can be executed by some trigger, and we can create a new instance. So in that case, the services can be used, like for monitoring, we have a CloudWatch. to store any data in between, like what the error would be there, we can use DynamoDB. CloudTrail is used to the complete trail, like from the request come from user until end the request has been responded, what all the tails would be there. SNS to send notification to operator, and EC2 instance to deploy the VMs or any, we can say any application. That's it. And these are the few serverless provider, not service provider. These are the company who opted for serverless, and like Delivery Hero, Neobank, the Wipro company. These companies has already opted and they have chosen serverless technology, and most of their software are already has on serverless. Okay. And this is the resources you can study. I can send over chat all the resources. The first article is the journey towards serverless computing. This is written by me, and you can find all the information which we have discussed today. Journey towards serverless, like that is up to the season, like we should go for serverless or not. You can find information here. And if you want to the introduction like serverless, Lambda, and DynamoDB, you can use this link. And the other is specific to, like if you want to understand the SNS, Lambda function, kinases, the step function, want to understand cloud HSM or Amazon Aurora, so you can use this link to understand each and every this service. So the common use case we have discussed, you can find all the use cases here. Okay, so that's it. Hello.
Yep. Okay, guys. So we're waiting for your questions, if you have any in the chat. So Ram, thank you very much for your talk. I hope it was useful, and I see a lot of comments in the chat that it is useful, and it was nice. So guys, waiting for your questions in the chat. So if you have any, please type them there. I have one here from Sunil. How can we overcome debug challenges on serverless?
Okay, so as I told earlier, I think in one of the slides, so there's a challenges that if we go for serverless, we have some issues to, we can say, debug at local. Okay, so that is the challenge there, and there would be specifically some tools there which we can use to overcome that. But if we want to deploy that, better to, we can say, we can have a similar application at our local, and we can try to deploy at local and without on the server. Then you can identify what are the, we can say, bug issues are there.
Okay, thank you for the answer. Let me check if I have any more questions here. I don't see a lot of them at the moment. So guys, if you will have any questions, please type them here in the chat. We'll have some more minutes here to answer them. While we're waiting for the questions, I want to say that in the description of our video, there is a link to feedback form. Please follow this link and leave us feedback for this webinar. So leave us your opinion, and we'll read all the feedbacks, so we'll be glad to read your opinion as well. Okay, we have one more question. How to solve issue with cold start when response time should be fast?
Okay, so we have a provisioning in AWS. We can have a provisioning. We can start. We can say we want the 5 stances or 10 stances are always up. So that provisioning we can do. Okay. I hope.
Okay. Yeah, I hope this may answer. So Alexander, if you have any more questions here, please type them. Okay, so I don't see any more questions at the moment. So maybe let's wait just a couple more minutes, and we'll have more. Also, I want to remind you, if you want to become a speaker on our JaCoV webinars, in the description we have a special email list, orgJaCoVCommunity@epam.com. So if you from EPAM, if you're not from EPAM and you would like to be a speaker on our webinars, please send us an email and we will help you to prepare your talk. So we're waiting for you. I don't see any more questions, so I think we may wrap up here. So Ram, thank you again for your talk. I hope it was nice, and guys, it was useful for you. Thank you very much for participating here with us, and thank you for this.
Yeah, thank you, Roman. Thanks for your support, and thanks, guys. So, if you want any information, you can ping to Roman, so Roman can connect with me, and I will provide all the information what you all required.
Sure. We will, you guys all who registered on CommunityZ will receive an email after this webinar with a link to feedback form. And I think we will include the presentation of RAM there also as well. So in case if you have any questions, ping us and we will try to help you with that. Okay. So thank you all. Thank you for this webinar. Hope to see you on our future webinars, and have a good rest of the day. Bye.
Bye. Bye, guys.